This is the first of 5 videos that will look at DC power supplies. We're first going to look at some of the basic terminology, some of the words that we're going to use throughout the unit. So rectification, the process of converting AC to DC, and you would have come across this when we looked at diodes. Usually that's the component that's used to turn AC, which is alternating backwards and forwards current, into direct current. Half wave, if we just use one diode, then we generally just get the first half of the waveform through, the positive, and we lose the negative, which gives us half wave rectification. If we use a center tap transformer or 4 diodes, then we can get full wave. And so the negative of that waveform, of the AC waveform, has been turned into a positive, and we've got both halves through as positive waveforms, full wave. Here's a center tap transformer that you should have come across. It's got the normal 2 tap-ins for the top and bottom of the coil, but in the middle of the coil there will be another tap-in, the center tap, and so we can get 2 voltages from it. A reservoir capacitor is a capacitor that's used to smooth the DC output. So we know this kind of bridge rectifier will give us full wave, but it will be very raw, pulsing DC. And if we put a capacitor across there, we can smooth that out, and that capacitor is known as a reservoir capacitor. When a transformer is loaded, the voltage will go down, so it can deliver more voltage with a lower load. If we load the transformer, that voltage goes down. And regulation is a measurement of how much voltage we lose. If you look at the calculation there, we've got the open circuit voltage, which will be quite high, the full voltage, which will be a little bit lower, divided by full voltage, and that will give us a ratio. And if you times it by 100, we can get a percentage. A 3-pin regulator is used to regulate voltage. So we've got the input here, output here, and a common. So if we want a regulated output of say 5 volts, then we supply 8 volts or 9 volts here, and this regulator will make sure that the output here is 5 volts independent of what current it takes or what loading is put onto it. So it's able to give us a constant output for a change in input, as long as we feed it with a few volts more than we want out here.